Today we will discuss some problems regarding how to find the significance level, power of the test, type 1 and type 2 error. So let's move on to the first question. So the first question here is given as a population has a PDF f of x, where f of x is equal to 1 by 4, and the range of x is also given over here, theta minus 2 less than or equal to x less than or equal to theta plus 2. And we are asked to test h0, that is the null hypothesis, theta is equal to 5, against h1, which is the alternative hypothesis, theta is equal to 8, based on a sample size of 1. It is suggested to reject the hypothesis if x is greater than or equal to 6. We are asked to find out the significance level and the power of the test. So I request all the students to please read the question thoroughly before moving to the problem. So so the solution. See, now let's have a close examine of our question. Now we are given with the PDF, that is f of x, which is equal to 1 by 4. We are also given the range of x, where that is theta minus 2 is less than or equal to x less than or equal to theta plus 2. Now here theta is the parameter. Okay, fine. What else is given? Yeah, we are given a null hypothesis, that is h0, theta is equal to 5, against, we are also given the alternative hypothesis h1, theta is equal to 8. Then what is the other information that we have? The sample size is 1. Then also we are given that it is suggested that to reject the hypothesis if x is greater than or equal to 6. So what is that? Yeah, we will have to reject the hypothesis if if x is greater than or equal to 6. So now what does that mean? Critical region. So that is your critical region. Now what is your critical region? Your critical region is x greater than or equal to 6. Then what are we asked to find out? We have to find out the significance level and the power of the test. So there are two things that you have to find out in this problem. Let's have a look at how to find out the significance level. Okay, so let's see significance level. How will you denote significance level? It is denoted by alpha, which is also equal to what? Probability of type 1 error, right? Now what is probability of type 1 error? Probability of rejecting h0 given h0. Okay, which is equal to probability of what is rejecting h0, or when is the case when you reject h0? Yeah, you have to write here your critical region. What is that? X greater than or equal to 6 given h0. What is your h0 in this case, or your null hypothesis? It is theta is equal to 5, right? Now how will you write this again? You have to convert this into an integral form. Now what is that? Integral f of x dx, right? But what is missing over here? Your limits are missing. And what is f of x with regard to this case? Let's have a look. Integral What is f of x? F of x is 1 by 4. So write 1 by 4 dx. What about the limits? Your limits are what? The highest value that you can, sorry, the lowest value that you can take over here is 6, since your critical region is x greater than or equal to 6. So you can write 6 here as a lower limit. Then what about the upper limit? Upper limit, we already know that your upper limit, what is your upper limit? What is the limit of x? Theta minus 2 less than or equal to x less than or equal to theta plus 2. Now this part you can take this as such because you are given a condition over here, so that's why your lower limit is 6. What about the upper limit? Yeah, you have theta is equal to 5, so 5 plus 5 plus 2 is equal to 7. So this is your upper limit. So you can write your upper limit over here. That is integral 6 to 7 1 by 4 dx. Now how will you integrate it? Yes, 1 by 4 is a constant. I took it outside. You have here x 6 to 7, which is equal to 1 by 4 into 1 by 4 into 7 minus 6, which is equal to 1 by 4. So finally this is your significance level, or this is your alpha. Okay, I hope you understood this. Now let's have a look at what, I'm really sorry for drawing a line like this. It should be a straight line. I very well know about that, but yeah. Now let's have a look at the power of the test, how to find out the power. So that was the second thing that we have to find out, power of the test. Now how will you find the power of the test? Let's have a look at the formula. Power of the test is also equal to 1 minus probability of type 2 error. Right, this is what you learned. Now what is type 2 error? Probability of type 2 error. Probability of type 2 error is nothing but probability of accepting the null hypothesis when your alternative hypothesis is true. That is probability of accepting H0 given H1. How will you write that? Probability of, see, probability of rejecting H0 is what? X greater than or equal to 6. So what is the probability of accepting H0? Yes, x less than 6 given H1. What is H1? Theta is equal to, just see the question, theta is equal to 8. Now how will you write this in terms of integration? Let's see, integral f of x dx, which is equal to integral, what is your f of x over here? 1 by 4 dx. What about the limits? See, x is greater than 6. So the upper limit, the maximum that x can take in this case is 6. Right. So that is will be your upper limit. What about the lower limit? As I said before, you know the range. What is it? Theta minus 2 less than or equal to x less than or equal to theta plus 2. So in this case, you have to take this theta minus 2 into consideration. 8 minus 2 is equal to what? 6. Instead of theta, you substitute 8 over here, you get 6. So again, this is 6. Now, what will be your answer? 1 by 4 into x, 1 by 4 into 6 minus 6, 0. So this is your probability of type 2 error. What is that we have to find out? Power of the test is equal to 1 minus probability of type 2 error, and that is equal to 1 minus 0, which is equal to 1. So this is your answer. Let's move on to the next question. So the next question is about what you are given the PDF f of x is equal to 1 by theta. There is a range for x that is 0 less than or equal to x less than or equal to theta. Now if you are testing h naught is h naught, that is the null hypothesis, theta is equal to 1 against the alternative hypothesis h1 theta is equal to 2 by the means of a single observation. They are asking what is type 1 and type 2 error if we choose the critical regions as x greater than or equal to 0.5, and also they are provided with another critical region 1 less than or equal to x less than or equal to 1.5. So let's have a look at the solution. Now let's write down the information that is given over here. We are given with the PDF f of x is equal to 1 by theta. We know the range of x, what is it, 0 less than or equal to s less than or equal to theta. Also we know the null hypothesis, that is h naught theta is equal to 1 against h1 theta is equal to 2. Now we have a single observation over here. What is the single observation? Single observation means what? Yeah, your sample size is 1. You don't have to worry much about this. Then you have two critical regions. That means you have to consider two cases for this question. The first critical region that you have to check is x greater than or equal to 0.5, and the second critical region is 1 less than or equal to x less than or equal to 1.5. Then we are asked to find out what type 1 and type 2 error, probability of type 1 and type 2 error. Okay, so case 1 when the critical region is x greater than or equal to 0.5. So this is the case 1 that I am going to deal with, and in this case you have to find out probability of type 1 error as well as probability of type 2 error. So what is probability of type 1 error? Let's have a look. It's equal to what? Probability of rejecting h naught given h naught, which is equal to probability of, what is rejecting h naught here, x greater than or equal to 0.5 given what is the h naught in this case, theta is equal to 1, right? So how will you convert this into an integral form? Integral, what is the highest, lowest value that this integral can take? 0.5, 0.52. The maximum that this can take is 1, because you know that the range of x is 0 less than or equal to x less than or equal to theta. So the maximum over here is 1. Put theta is equal to 1. Okay, then f of x, instead of f of x you can write what? 1 by theta, or 1, theta is equal to 1 dx. So that is equal to what? Integral 0.5 to 1 dx, which is equal to x 0.5 1, which is equal to 1 minus 0.5, that is equal to 0.5. So this is the probability of type 1 error when the critical region is x greater than or equal to 1. Now let's have a look. When x greater than or equal to 0.5, what will be your probability of type 2 error? This is equal to probability of what? Accepting h naught given h1. Okay, so how will you write that? Probability of, so see, rejecting h naught means x greater than or equal to 0.5. Accepting means what? X less than 0.5 given h1. H1 means what? Theta is equal to 2, that is equal to integral, uh, it is 1 by theta over here, 1 by theta equal to 2 dx. What about the limits? Here the maximum limit it could take is 0.5, and the lowest limit, what is it? See, we know that x takes the value 0 less than or equal to x less than or equal to theta, so the lowest value is 0, which is equal to what? 1 by 2x, right? 1 by 2x, 0 to 0.5, which is equal to 1 by 2 into 0.5 minus 0, that is equal to what? 0.25. So this is your probability of type 2 error when the critical region is what? X greater than or equal to 0.5. Now case 2. Case 2 is when your critical region lies between 1, also 1 is included here, 1 less than or equal to x less than or equal to 1.5. So case 2 is this, and here let's have a look at your type 1 error. Okay, here also you have to find what? Type 1 and type 2 error. So what is your type 1 error? As usually it is probability of rejecting H0 when H0 is given, that is equal to probability of 1 less than or equal to x less than or equal to 1.5 given theta is equal to 1. Okay, so what is this? Probably, okay, how can you write this? Yeah, it is nothing but what? Integral 1. So here it is clearly given, the lower bound is also given, and the upper bound is also given. So you can clearly say that 1 to 1.5 1 by theta dx, which is equal to what? Integral x 1 to 1.5, which is equal to what? Okay, now in terms of integration, let's have a look at the lower bound. What is the lower bound over here? Lower bound is 1. What about the upper bound? Upper bound is nothing but we know that the value of x lies between what? 0 less than or equal to, less than or equal to x less than or equal to theta. Now theta over here it is 1, right? Because it is given what? H0, theta is equal to 1. So here theta is equal to 1. So you can write here as 1. Then what about f of x over here? F of x is 1 by theta, which is equal to 1 dx. So what is it? X 1 the bounds are 1 to 1, and that is equal to what? 1 minus 1 equal to 0. So the probability of type 1 error in this case is 0. Now let's have a look at the probability of type 2 error in this case, that is when the critical region lies between 1 and 1.5. Okay, so what is probability of type 2 error? Probability of accepting H0 when H1 is given. Now what does that mean? Probability of, see, probability of rejecting H0 is what? this, right? So what will be probability of accepting h0 in this case? So for that I'm going to show you one thing. That is, I'm going to draw a number line. Okay, now let this line starts from 0, 1 and 2 over here. Okay, so somewhere over here is your 1.5. So it is said that 1 is also included. 1 to 1.5, this region is actually what? A rejection region. According to your question, it is the rejection region. Okay, and we know that the range of x is 0 less than or equal to x less than or equal to theta. Now you have the alternative hypothesis as h1 theta is equal to 2. So the maximum value x can take is 0 less than or equal to x less than or equal to 2. So that is why I put a 2 over here. Okay, so what is your acceptance region? Other than the rejection region, what all region will be there? It is your acceptance region. So your acceptance region is actually from 0 to 1 and from 1.5 to 2. So 0 to 1 and 1.5 to 2. So this both will be your acceptance region. So how will you write your acceptance region in terms of probability? Probability of 0 less than or equal to x less than 1 given h1 plus, so this one is considered, plus probability of 1.5 less than x less than or equal to 2 given h1. So this is your acceptance region. Now how will you write this in terms of integration? Integral 0 to, so this is h1, so integral 0 to the maximum value that you can take is 2, but since you have the integral as the range as 1 over here, you can take 0 to 1 f of x dx plus integral 1.5 to 2 f of x dx. This is equal to what? Here in the place of f of x you can write 0 to 1 f of x. What is your f of x over here? 1 by theta. 1 by theta is equal to 2. Here you have h1, so yeah, dx plus integral 0 to 1.5 to 2, 1 by theta is equal to 2 dx, which is equal to what? Which is equal to x by 2 0 to 1 minus x by 2 1.5 to 2, which is equal to, just do the calculations, simple calculations, you will get 0.75. So this is the probability of type 2 error.